Okay, hello and welcome to math. Let's do the review solutions. So, a lot of these, again, we're gonna do the A version and the B version separately, but one page at a time for each. Okay, so you should be getting super comfortable with these distribution problems for now. If you're not, definitely come see me. So these parens here, really meaningless. So this is 5x plus 2x minus a half equals 1. But here I need to distribute that to both of those. So it's going to be minus 3 plus x. Let's combine these. So I get 7x minus a half equals 1 minus 3 is negative 2 plus x. I'm going to combine my x's. So minus x plus a half, and I'll get kind of a black and orange Halloween theme going here. 7 minus x is 6x. Those sum to 0. Negative 2 plus a half is negative 3 halves. I should do that a little bit better for you because this is negative 2 times 2 over 2, which is 4 halves. So negative 4 halves. So negative 4 plus 1 is negative 3. And then these sum to 0. So that's all I have there. So I'm going to then divide both sides by 6. So really I'm going to make that times 1/6 because multiplying by the reciprocal is so much simpler. Those go away, and I get x equals negative 3 halves times 1/6 equals negative 3 over 2 times 6. And from that, I know negative 3 goes into itself one time, and 6, so actually that's negative 1. 3 goes into that, negative 1 times, 3 goes into 6 2 times. So I get x equals negative 1/4. And we're done. Now here, just because I put x in the bottom of two different expressions shouldn't freak you out. You should notice that this is an expression. So we can only multiply. Oh, golly. Come on, don't do that. Multiply by 1. Just trying to get rid of the message, and I tapped on it accidentally. So we can only multiply by 1. So I'm going to rewrite this down here. Give myself some room. 3 over 5x minus 2 over x minus a half. I think I want a common denominator of 10x. So what I'm going to do is multiply this one by 2 over 2, this one by 10 over 10, and this one by 5x over 5x. This is to get a common denominator of 10. So then I get 6 over 10x minus 20 over 10x minus 5x over 10x. Adding them together, I get 6 minus 20 minus 5x all over 10x, which is negative 14 minus 5x over 10x. Done. God, those are so much easier now than they were at the beginning of the year. You guys are amazing. And here I've just given you a plain vanilla, it's no x's even. It's an expression, check. And I'm going to have a common denominator denominator, such a long word, of 6. So I'm going to rewrite same way, 3 over 2 minus 11 over 3, give myself some room, plus 5, and common denominator of 6, whoops, 3 over 3 to get my common denominator, 2 over 2 to get my common denominator, 6 over 6 here. So I should have 9 over 6 minus 22 over 6 plus 30 over 6. So I'm going to rewrite that as 9 minus 22 plus 30 over 6, which is the same as 9 plus 8. Because these, negative 22 plus 30, I'm going to choose to do that first. That's 8 over 6. So 17 over 6. And that reminds me that I made a boo-boo on my, here we go, answer key. There we go. I wrote 27 instead of 22. Well, actually, I wrote 22, but read it as 27 because my handwriting was so bad. All right, let's do the B version of this page. This should not throw you here that we have x's on both, on 2 of the denominators. We're still going to have a, first of all, you need to note that this is an expression. So can only multiply by 1. But also we are going to make a, so check, I've noticed that, check, I'm going to have a common denominator of 10x. Oh, it's not an expression. God, what a dork I am. In the other one, it was an expression. Sorry, my bad. It's an equation. So we actually can multiply by anything. If we do it on both sides, do it to all terms. So I'm going to got 3/5 minus, oh, I'd rather do that in black. 3/5 minus 2 over x equals 1 over 2x. So I am going to take, I'm going to take my common denominator, I'm going to multiply by that times 10x. And I like this because it kind of does neat things for me. I do end up with something that looks like this. I'm going to write it out. So 10x times 3 over 5 minus 10x times 2 over x equals 10x times 1 over 2x, right? So I'm just doing the multiplication here of this times that, times that, times that. And then notice what goodness happens here, right? So 5 goes into 5 once, goes into 10 2 times. So what I end up there with is 6x, right? The denominator's gone away, and that's all that's left. The x's here divide out, so I'm left there with just minus 20 equals, and then here the 2x goes into 2x once, goes into 10x 5 times. So that's just 5. So 6x equals, I should write down my steps, plus 20, plus 20. 6x equals 25. And then dividing by 6, I get x equals 25 over 6. Let's make sure that jives with what I think I was supposed to get. Oh, my pages are in the wrong order. Oh, did I? Oh, shoot. Okay, well, we're going to make it an equation because, yeah, it is an equation. I think on the answer key originally I made it an expression, and then this is right. So I'll give you guys the equation. I'm so kind to you. All right, notice here, these are sort of actually, these are meaningless. They're not doing anything. So really what I have here is 5x plus 2x minus a half, because there's nothing to distribute across them. There's no multiplication across them that's happening. Equals 1. And then notice here, though, these are not. Like, I have to distribute this to both of those. So here we've got distribution. So it's 1 minus 3 plus x. Don't lose that bad boy. So now I'm going to combine them. So I've got 7x minus a half equals negative 2 plus x. Let's subtract x from both sides. So those will sum to 0. And add a half to both sides. So those will sum to 0. So 7x minus x is 6x equals, I'm going to write negative 2 plus a half, give myself some room, and that x goes away. So I want a common denominator here, so I'm going to multiply it by 2 over 2. So that equals negative 4 over 2 plus 1 over 2, which is negative 3 over 2. That's 6x. So I'm going to divide both sides. Well, I'm going to multiply both sides by 1/6 so that these go away. And I'm left with just x equals. And then 1/6 times that is negative 3 over 2 times 6. I love to divide things out early, so 3 goes into that 2 times, 3 goes into that negative 1 times. So we have x equals negative 1 over 4. Shazam. And then just a plain old fraction expression. But note a couple things. One is this is an expression. So we can only multiply by 1. And I think we will say we're going to use a common denominator. Wow. Denominator. That was my computer. I must have gotten an email or something, but it was uncommonly loud. Common denominator of 6. So let's rewrite it, give ourselves some space. 4 minus 8 over 3 plus 5 over 2. Our common denominator is 6, so we're going to do 6 over 6 there, 2 over 2 here, and 3 over 3 here. So that we get 24 over 6 minus 16 over 6 plus 15 over 6 equals 24 minus 16 plus 15 all over 6. And so this minus 16 plus 15, I like doing that first. That's just equal to minus 1. So 24 minus 1 is 23 over 6. And we're done. On we go. Domain and range. So domain here, I'm going to do domain blue. We're talking about the x-axis. The lowest x-axis is 0. It happens right there. And all of these get used all the way out there. And note that there should be, hopefully, I always forget to do it, but on the end of that, there should be an arrow, right? So my domain is from 0 to infinity. Nice, 3 zeros. And my range, I will do in red. The lowest y value here is -3. And it'll just keep going up. All of those y values get used. So -3 to infinity. Hopefully that was the easiest problem in the whole quiz. This is a little funkier, right? I did get arrows on these. The domain starts way out here. Like, because this arrow just keeps going out that way, we start at -infinity and we go all the way up to here. But then we have a full stop and there's a gap. And then we start again there and we're using all of those x's out to +infinity. So our domain is -infinity to -1. And 1 out to +infinity. Our range is similarly weird, but in a slightly different way. It's definitely going down here to -infinity, and it uses all of these. But the highest plan, and in fact, once we get up to -4, then it's used, twice. Actually, -4 is used 4 times, right? But it's okay. If it's used multiple times, it's used at least once, but it goes all the way up here to 0, and then that's the top. So -infinity up to 0, and that's our range. Okay. Of course, I forgot to put an arrow on this bad boy again, but it does go out for infinity. So our x values start here at -4, and all of these values on the x-axis are used somewhere on the curve, and they go out to infinity. So -4 out to infinity. And our y values, the lowest y value is that point at 0. And then all of these values on the y-axis get used at some point, and they go up to +infinity. So 0 to +infinity. Hopefully that was the easiest problem on your whole quiz. This one's a little funkier. I did not get arrows on these. I did on the other classes. I gotta remember to just draw these in. I get so excited that I'm at the point where I'm printing. I should just draw them in. So because of that, our x values actually get used all the way out to -infinity, because this is just gonna keep going on. So -infinity, it go all the way to here, and then it stops right here at -1. So it goes from -infinity up to -1, and it stops there. And then it starts again at +1, this is used here, and keeps going out to +infinity. So 1 out to +infinity. Our y values, similarly, the lowest y value that gets used is here at 0. And everything from 0 upwards always gets used. In fact, between 0 and +2, it gets used like, each y value gets used 4 times. After that, they get used twice, but it does go all the way to infinity because all of them appear in some point on the graph. So we start at 0 and we go to +infinity, and that's our range. Make a t-table with at least 3 points that lie in the graph. I hope, though I don't know how it will go, that you all look at this and you get this big happy grin on your face, because I can do immediately 2 easy points. When x is 0 and when y is 0. So when x is 0, I have 3 times 0 minus 5y equals 15. Well, not sure why that did that. So that means minus 5y equals 15, divided by -5, and y equals -3. when y is 0, we have 3x minus 5 times 0 equals 15. So 3x equals 15 and x equals 5. From there, you could put in just about anything you want and just get one other sort of unusual one. I think I did x equals 1, yeah. So I'll do it in green. 3 times 1 minus 5y equals 15. So I'm going to subtract 3 from both sides, and I get minus 5y equals 12. And then divide both sides by, or multiply both sides by negative 1/5. And I get y equals negative 12/5. So when x is 1, y is negative 12/5. So I got my 3 points there. The super easy part about these first two is that's all I really need to graph. So I'm going to take 0, negative 3 there. Oh, that might be in my way when I start to draw my line, so I'm going to move that up. And 5, 0 here. Whoops. 5, 0 here. And that's my line, so I'm going to attempt to eyeball this line. There we go. And this is 5, 0. So I have labeled my x and y intercepts clearly. I've got the function on there. I'm going to write the function. So this is 3x minus 5y equals 15 so that I remember which one it is. And then in the next question, I have to find the intersection point between the line and this line. So this is a similarly easy line to graph, and I'm going to do the exact same thing. When x equals 0, that means y equals 3, just looking at the equation. And when y equals 0, that means x equals 3, right? Just looking at them, plugging in. When I plug in x equals 0, then y has got to be 3. So that gives me my 2 intercepts, one there and one there. I can eyeball my graph like that, roughly speaking. This is x plus y equals 3. I'm like, okay, so that helps me because I know there's my intersection point. It's roughly between 3 and 4 on the x-axis and between 0 and negative 1 on the y-axis. So what I'm going to do is I am going to, so step 1, well, maybe I should do it over there. Step 1, I'm going to put both in y equals mx plus b form. So my green one will be y equals negative x plus 3. I think just subtract x from both sides. And my blue one, let's do it here. Negative 5y equals negative 3x plus 15. So I just subtracted 3x from both sides. And then I am going to multiply both sides by negative 1/5 so that that goes away. And I'll get y equals positive 3/5 minus 3. That's really 15 over 5 is 3. So, oh, and I forgot my x. So I'm going to write that down here. Y equals 3/5 x minus 3. And then, so this is my first step. My second step is to set the y's equal to each other. Because I know that I hate it when that happens. I know that they will be the same thing at the point where they cross. So I got to find out what x makes the y's equal to each other. So if I think of this as y1 and y2, then really I want the point where y1 equals y2, which means that minus x plus 3 has to equal 3/5 x minus 3. So let's solve for that. Plus x plus 3 plus 3. So those sum to 0, those sum to 0. What I get is 6 equals 3/5 x plus x. And common denominator, that's really 3 over 3. Oops, sorry, not 3 over 3, 5 over 5. 5 over 5x. So 6 equals 8/5 x. Oh, come on. 6 equals 8/5 x. Multiply both sides by, let's move this over. I didn't give myself enough room. And the arrowhead got moved. Okay, so multiply both sides by 5 over 8 so that those cancel out. And I get x equals 30 over 8, which is the same as 15 over 4. So that's my x value. And then to find my y, y equals the opposite of x, so the opposite of 15/4 plus 3. I'm using, I don't know how well to do this. Find y from y equals minus x plus 3. I can just plug it back in. So if I multiply this by 4 over 4, whoops, I can say y equals minus 15 over 4. Yeah, minus 15 over 4 plus 12 over 4 equals minus 3 over 4. So that gives me a point of 15 over 4 comma minus 3 over 4. And if I look at that, this is, I'll do it black. This is 3 3/4 comma negative 3/4. And that's about what we expected here. So 3 3/4 comma negative 3/4. Check. That looks about right. Okay. Make a t-table with at least 3 points that lie on the graph. Okay, we are immediately going to do, let's see, in black we'll do when x equals 0, what's y? So that would be 5 times 0 minus 4y equals 20. So minus 4, because that's nothing. Minus 4y equals 20. Divide both sides by 4, we get y equals negative 5. Let's immediately try when y is 0, because that's a good one. So 5x minus 4 times 0 equals 20. So 5x equals 20, x equals 4. And then we can plug in kind of whatever else we want there. Let me turn my page. Oh, I didn't even do this. I got lazy as I was doing the key. So I'm going to plug in, let's say, x equals 1. So 5 times 1 minus 4y equals 20. So minus 4y equals 20 minus 5, which is 15. So y equals 15 over, negative 15 over 4. But that's pretty cool. Now, this third point was just, the annoying math teacher question that I don't actually need to be able to graph. These first 2 points, it's by far the easiest way to graph. And one thing I love, sorry, I got a little hiccup there. One thing I love about this form here, is it's super easy to create these 2 points, the x and y intercepts. So 0, -5, and 4, 0 looks like that. And if I kind of, whoops, come on. If I eyeball the line, it looks like that. I'm going to label it with 5x minus 4y equals 20. And by the way, I'm going to save that space over there to do a little bit of work. Make sure that I label my x and y intercepts. So this is 4, 0 and 0, -5. And I think I'm done with that question. Now I've got this other one. Now notice I can do the exact same set of points to graph this. It's really easy. I love this form of the equation. Here, when x is 0, y is clearly 3, right? When x is 0, that goes away, and y equals 3. Similarly, when y is 0, x is 3. So super easy to graph this thing. I will do it in green. There's one intercept, there's another intercept. And if I eyeball it, it looks like that. Ew, that was not well done, did not turn out right. There we go, that's pretty good. My green has turned into sort of a turquoise there. It's a little aqua. This is x plus y equals 3. Now, if I got to find the intersection point, I would love it if they were both in y equals mx plus b form. So I am going to say that's my first job. Step 1, I would like that. So I'm going to take and do it here. I'll do it in blue again. So if I add or subtract 5x from both sides, I get minus 4y equals minus 5x plus 20. And then multiply both sides by -1/4. That goes away, and I am left with y equals, do this to both of those, positive 5/4 x minus 20/4, which is y equals 5/4 x minus 5. Well, I could have seen that, actually. You know, we should have been able to say, okay, look, I can see clearly that the slope here is a rise of 5 and a run of 4, and I know what the y-intercept is. So that would have been easy if I just looked at the graph. Here, this is clearly, if I just subtract x from both sides, y equals minus x plus 3, and we're done there. That's also something I could have seen from the graph. So I've got them now. y1 equals 5/4 x minus 5, and y2 equals minus x plus 3. So my step 2 is I want to know if there's an x value that, let's move this up, makes y1 equal y2. Okay, well that's easy enough. So if I want to know where y1 equals y2, then that means that 5/4 x minus 5, which is y1, has to equal minus x plus 3, which is y2. So let's see, add x to both sides and add 5 to both sides. Those will be 0, those will be 0. And we will get 5/4 x plus 5/5 x, right? That's just 1x equals 8. So, oh, why did I say 5/5? Eraser. 4/4. I want a common denominator, right? 4/4 x. So 9/4, stop with the updates, x equals 8. Let's multiply both sides by the reciprocal. Boom, 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 boom. We get x all by itself. X equals 8 times 4 is 32, so 32 over 9. And let's see if I managed to agree with what I wrote. Yep, there we go. So this is our x value, not the end of our answer. Step 3, plug to get y. So I'm going to plug back into to that one. So 32 over 9 plus y equals 3. So y equals 3 minus, whoops, I needed more space there. No, let's just do that. 3 minus 32 over 9. I need a common denominator, so let's make it 9 over 9. So y equals 20, let's put those in parentheses, 27 over 9 minus 32 over 9, which is clearly negative 5 over 9. So our point then is, by the way, that's our y, 32 over 9 comma negative 5 over 9. And I think, first let me do my, yep. And I think if we look on the graph, 32 over 9 is a little bit over 3. Yep, so my x value is kind of right in there, and my y value 5 over 9 is probably about there. That seems about right. Okay, last little thing here, graph this. Notice I forced you to have negative 2 in the middle, so that means we'll go negative 1, 0, negative 3, negative 4, like that. And just plugging them in, I should get, so 0 plus 2 is 2, 2 squared is 4, 4 minus 5, so 2 squared minus 5 equals negative 1. Here, negative 1 plus 2 is 1 squared minus 5 is negative 4. And negative 2 plus 2 is 0, obviously. So we got 0 squared plus, whoops, minus 5. Negative 5. And here, this is negative 1 squared minus 5 is also going to be negative 4. Negative 2 is what we get when we add negative 4 plus 2. Minus 5 is going to be negative 1. So what we end up with is negative 2, negative 5 is here. And then we have a point there at negative 1, negative 4. And then another point at 0, negative 1 here. And matching points on this side at negative 3, negative 4. And negative 4, comma negative 1. So this is a parabola that looks roughly like that. There we go. Done. And one more. You guys got the absolute value. Lucky you, lucky you. And I forced you to have 2 in the middle here. So this is going to be 0, 1, 2, 3, 4. Because I wanted you to center it around 2. Why? Because the absolute value of 2 minus 2 is the, oh, come on, pen. Absolute value of 0 minus 4 is negative 4. So right there is our first point, 2 comma negative 4. Absolute value 1 minus 2 is the absolute value of negative 1 minus 4 is 1 minus 4, which is negative 3. So right right there. The point is 1 comma negative 3. Absolute value of 0 minus 2 is the absolute value of negative 2 minus 4 is 2 minus 4 is negative 2. So right there. Add 3 minus 2 is the absolute value of 1, which is just plain old 1 minus 4. Is also negative 3, and that's here. 3 comma negative 3. And then 4 minus 2 is 2, so absolute value of 2 minus 4, negative 2. So we have this thing that's looking very linear. Sorry, I have to turn to be able to draw reasonably straight lines. There we go. And, oh, if I didn't finish labeling my points, this is 0, negative 2, and this one is 4 comma negative 2. Has a nice symmetry to it. And we're done. Have a delightful day.